Let's do it. I have your permission. Okay, let's do it then. Okay, so that's my name. I'm Luca Bolognese. My story is I now work for Credit Suisse, and we just opened a branch. We're just 3 years ago we opened the branch here. And before Credit Suisse, I was working for Microsoft in Redmond, and I was responsible for most of the compilers, for the C#, the F#, and the Visual Basic compilers, and the IDE. And I worked there for 10 years, so for quite a long time, I would say. This presentation, usually when I give presentation, I kind of know what I'm talking about. This time around, it's a bit dubious. So this is not a presentation on a program that I have developed, that I know everything about, that I can answer question, very precise question and everything. This is more of the speculative kind of presentation. I'm going to show you some code, run some code, make some statements, but I don't have the same level of knowledge on this stuff that I have on things that I actually I've been working on for 10 years. But still, I hope it will be of some interest. If not, that's fine. So, okay, so first of all, why someone would care about different paradigms of writing code? Why not just getting better at how we write code today? Why the status quo is not good enough, in a way? Why would you care, right? So there are a few things. First of all, we are not doing very well as a profession. We are doing rather badly. Overall, we might use all the latest fads, the template-based programming and test code and continuous integration. We can have all the buzzwords that we want in a row. But the truth is that most software projects fail, most of them. And the ones that succeed usually deliver half of what they promise in double the time. So we're not doing really well. So one might want to question the way that we write code. Perhaps there is something wrong in the way that we do write code, and it's not, it's not just the fault of the manager up there that is telling us, is giving us impossible tasks. Maybe there is some fault in the way that we do things. And so that's one consideration. My other consideration is now I've been in this business for more than 20 years or so. I see someone here that has been even more, perhaps. And the number of fad that you hear in this business, one day is testing, test-driven development, no, it's behavioral-driven development. You go all this cycle of things that supposedly, make you as a programmer better and make things better. And then you're at the end of all these fads, and the number of projects that succeed is the same that 40 years ago, when we weren't doing any of that. I mean, it's true that the projects are getting more complex. 40 years ago we were building a compiler, now we are building software for an airport. So the projects are more complex. But it's also true that perhaps a lot of those, we are not as good as other professions in incrementally building our knowledge towards something that is actually good. We more like we swing. One season is this, the other season is that, and it's unclear if that is better than this. And I've seen many things that have been considered, first class, you got to do this, if you don't do this, your project is doomed. And then, in 5 years, that's the wrong thing to do, man. How can you think of doing it that way? So I'm a bit also, my lack of satisfaction toward this way of operating. And also, to be honest with you, a lot of time I look at code, and it takes me a very long time to understand what the hell this code is doing. And the problem is, most of the time, it's my code. So you might say, all right, your code really sucks, man. You might say that. But when I talk with other people, they have the same problem. Code that they have written, 3 years ago, 2 years ago, they look at it, it's like new. You got to go and try to figure out what you were thinking at the time. All the knowledge that you had at the time, all the careful, I have a library that downloads stock prices from Yahoo, for example, right? Seems like a trivial thing, but the truth is that there are a lot of subtleties. Yahoo screws it up in many different ways. The dividend is not, you know, is not ported to the current value. The number of the adjusted price is wrong. They don't have enough. So I knew all these things, and I embedded all of them in this library 4 years ago. Now when I look at it, you know, man, I don't know. You know, I multiply this by 200. Well, must be good. You know, I run my test cases, it passes. Yeah, cool. But, you know, but am I really confident that my library is doing the right thing? I've got no idea at this point. I was confident, you know, 3 years ago for 3 hours. Now, you know, 3 years go by, I'm not so sure. So there is perhaps there is something that as professional we are not doing it right, perhaps. So that's what kind of makes me look at other ways of doing it, you know, more radical ways of doing it. And there are a bunch of things that I've looked at. There is formal verification of programs. There are a bunch of things that might be interesting. This is just one of them. It's not the best one. It's not preferred. It's just one of the things that are different, that are out there. So where does literate programming comes from? So Donald Knuth, I hope you know who he is. It's, in essence, is one of the genius of our profession. He wrote, you know, The Art of Computer Programming that everyone knows but no one has read. And he coded TeX, which is, you know, the language that is the basis of LaTeX and everything else. He coded a whole bunch of stuff. And the thing that is particular to me about this guy is that he pays money for any bug that you find, either in his code or in his books. Think about that for a second. He pays money, his own money. How many of you are confident to pay money for bugs in your code? Which level of confidence do you need to have to go to that point, right? And so that's what kind of impressed me about this guy, apart from all the other accomplishments that, you know, are impressive on their own. And what he thought is that this way of writing code is what allowed him to have that level of certainty, to have that, to do that. He thought that this was the way of the future, and he was wrong, because this happened, you know, 40 years ago or so, and no one pretty much has used it. So you might consider this as a failure, as a paradigm, a real failure. But then you have to ask yourself, is it a failure because it's wrong? Or is it a failure because he never got into the fad business, or he never be, you know, fad enough to be cool? And a lot of things that are out there, they failed not because they are bad. They just failed because something happened. And something else came along, and random things. So I got interested into this stuff, but what is it? So the main idea of this stuff is that when you write code, you shouldn't be thinking of the compiler. You shouldn't be thinking of what your code is doing. You should be thinking of that you are communicating with another human being. Okay? So that is the main difference. You are writing code, you are not writing a loop. You are telling to a colleague what you are trying to accomplish. And then, after you have explained what you are trying to do, then there is a little bit of code that does it. But your main focus is not on the code itself, but is on the explanation. And you should write your code as you would explain to a new joiner that is joining your team. So if you have any piece of code that you have written, if someone comes and tells you, well, why don't you walk me through this code, right? You don't start top to bottom, right? You see, all right, so the main part of the code is this loop here. And then in this loop we call that function over there. And then in that you do this, and then in that you do this. And what this says is that you should write your code in the same way. So the first thing, your code should be the main thing. And it should be what you're telling a colleague to look at if he has to understand your code. Then there can be a detail, then there should be... So the order of exposition is not the order that makes the compiler happy. is the order that makes another human being reading your code happy. Okay, is that clear? Mm-hmm. Also, the other thing is that once you have written your code, it should be as good that you can just print it and you have a book that is your code. And when a new joiner comes and say, so all right, why don't you teach me about my code? You go, oh, there you go, it's the book. So that's the idea. And if you go text, for example, if you look it up, text, there is a book of text, which is exactly that. It just is programmed, printed as a book. Okay, so that's the idea of literate programming. And then there are some quotes there and stuff, if you want to amuse yourself with quotes. All right, so there are, despite the fact that the old paradigm has been a failure, there are some projects that have been written in this way. There are some books that have been written in this way. There are some tools out there that indeed support this way of writing code. So why did I write in my own? I'm not going to answer that. Anyway, there are a different interpretation of this thing. The classical one, which is what NET work on, is you write code and then you have a program that goes through your code, it spits out the code that then your compiler compiles, and it spits out the book that then you do. So what you write on is a bit of a mix between code and verbiage, code and text. And then this generates the code and generates the book. That has a number of issues. The main issue is that all the tools that you're used to, like IntelliSense or even source control or all of these things, they don't understand this hybrid thing that is a bit of word and a bit of code. So it doesn't play too well with all the tooling. And then there is this code generation that is kind of awkward. You end up, when you go and debug your code, what are you looking at? Where is it? The source is not what you wrote. It's what has been generated by the tool. So it's a bit of an awkward way to, in my opinion, there are people who like that very much. In my opinion, it's a bit of an awkward way to go about that. There is Literate Haskell, which is pretty good actually. Literate Haskell, you write your text normally, and you just prepend the pieces of code with one particular character that tells the compiler that is indeed code and not text. And then my approach, which is what I think a pragmatic one, in essence you write normal comments in your code. It's just that your comments has a particular tag and your code works, IntelliSense works, everything works, but you just embed enough information in the comments so that then you can go and generate a book out of it, like a PDF or a web page or whatever else you want. You might think that this is the same as documentation. That's not the case. It is a very different concept. When you're documenting code, you are writing some snippet that describe a user of your function, of your library, what to do. When you're doing this, you are describing what your code does. You are describing all the assumptions in your code. You are describing what you were thinking in the moment when you wrote the code. Okay? It's not the same as going afterward and putting, Java doc tags or things like that before your function. You write this before you write the code. You don't write this after you have written the code. Okay? Okay, so just to give you an idea of what these things look, this is C-Web, which is the one that you separate things, and to be honest, to me, it looks rather messy. So I don't like it very much. Literate Haskell, I think it's pretty good. In essence, you write your text up there, and then you have this tag here before you get to the code. I think this doesn't look too bad. I mean, the tag is a bit dubious, but overall it doesn't look too bad. And my stuff looks like this. In essence, you prepend with this double. This is F#. The comments in F# are written like that, but just with one asterisk, and instead you use two asterisks. And then the things that you have here, like that one over there says that this is a chapter heading in the book, and this one says that this is a section heading, and so on and so forth. But if you read it normally, you should read like normal ASCII text without any of the crazy symbols that you see here, for example. All right, to give you, and this is, you know, obviously kind of it works for any programming language that you want. Now, the objection we're going to do later. Let's first take a look a bit of the code. Now, I think what I've said to this point is the most interesting part of the talk. If that was boring for you, what's coming is even worse. So, yeah, so now I told you. Okay. I don't know what I'm doing now. Yeah, here it is. All right, so what I'm going to do now is I give you an example of you know, medium-sized project kind of thing written in this style, and I'm going to explain what it is. And this medium-sized thing is exactly the tool that generates the book, that generates this thing. So it's written in its own style. Perhaps I should talk about the architecture a little bit. What happens is that I have a little tool, it's very simple, that takes a source file in whatever language. It looks for those particular annotations that you have in your comments, and it spit out a markdown file that has all the, you guys know what markdown is?
Yes.
Yeah, okay. So it spits out a markdown file that has all the right annotation before code and such, so that then you can take this markdown file and generate a PDF out of it, a HTML file, you know, or you know, a Word document, whatever you want. And I'm going to show you all those things here. So this is the code. Usually, this is about the ratio that I would expect of writing to kind of to code that you might expect. So this is what the program does. First, sorry? Oh.
Can you increase the font?
Oh, sure. Apologies, let me do that.
Or just Ctrl plus.
Yeah, maybe. But that's gonna increase everything. Well, better than crashing Visual Studio. It's coming back, it's coming back. F8. Okay. Then if we are doing it properly, let's do this as well. It's better. You can read it from back there. Yeah? Yes. All right, so the parameters that this thing takes are either the name of the language that you are processing, and then in that case, I know that for C, for example, this is what I'm looking for. For C#, this is what I'm looking for. For F# is something else. Or you can pass directly the kind of what are your delimiter for your narrative. So if you have a new language that doesn't use those delimiter, or if you want to do something else, you can do it. So yeah, this is not interesting. So here what I said is that some programming language, one of the problems in using this style of coding is that some programming languages don't allow you to declare your functions before you actually write them. So in those programming languages, it's very difficult to have an order of writing your code that is the order that a reader would like, because the compiler forces you to specify your function before you use them. And that's completely defies the purpose of this style of writing code. Because if the order is not what the reader will see, then the book is unreadable and the whole thing falls apart immediately. And there are many tools out there that support literate programming, but they do not have a solution for this problem, in which case they are useless in my view. F# is one of those languages where you do have a problem. because in F# you need to write your function before you call them, and order is important. C and C++, that's not a problem. You can declare your thing and then use them without defining them. But for F#, that's a problem. But so I came up with this trick, this little declare function that is a dirty trick, but it allows you to do a similar thing. So, okay, so these are the things those are the options that you can pass to the tool. Either you want your code generated as indented, or you want your code to be generated surrounded by tags that define which language you're using. And those are two different ways that Markdown represents things. And here, this is what the symbol that you want to start your narrative, to end your narrative, and to specify your code. So this is what the program does. Okay, so that's what I mean when I say you start from the very top. This is what the program does. This program is a translator that takes some option here, a string, which is the text of the program, and generate another string. If you were describing this program to someone, this is how you would talk about it. And in fact, this is after the description of the options, this is the very first thing that you see in the code. And also there is an explanation at the top that tells you what that is. And then, what it is in essence, how much time were you? 6? When did you start? That's
6:30.
6:30? Or I'm going to finish way early. Well, anyway, so now we get into what this code, how the code is structured in the middle. So there are two kinds of block. One is the code, and the other is the narrative. And again, there is a function, block I, kind of a bizarre name, that goes from an option and the text to a list of those blocks. Okay? Because if you think about it, it's narrative and code in kind of in that fashion. So here again, some description of what I was thinking at the time. I was thinking, yeah, can I just do a regular expression that changes some characters? Yeah, probably I could do it, but the problem is that when I want to add feature then, for example, I want to add the capability to refer from one block to a block that is defined in a different file, then a regular expression are not going to work. There I really need a compiler that takes those blocks and has a notion of what they are. And so here I'm saying why I thought that was the case. At the same time, I'm also saying, why don't I use fparsec for this instead of crafting my own parser? And there is my poor explanation of why I'm doing that. But that's the concept. I'm not trying to describe the program, I'm describing kind of the style of this. So when I went back after 2 years looking at this, I said, well, why didn't I use yeah, that's why I didn't use fparsec for this thing. So it kind of remember this information, if you wish. Then it's like a normal compiler. You've got a lexer here that just goes through, and it has these tokens. Is then an open comment, a close comment, or text, and then it tokenizes this. This is like compiler 101 kind of thing, and this tokenized function returns, a list of tokens. That's like, all the lexers do. And then you go and then you have your parser. And at the level of the parser, your parse tree looks like either a chunk of narrative or code, and this takes a sequence of tokens and give you back a list of chunks, and so on and so forth. There is a flattener that does kind of merges things if they are together, if they are kind of separated, and then finally. Now we have implemented the function that we defined at the very top. So we defined what we wanted to do, we defined the phases, and now the implementation is just, I'm sorry if you guys are not familiar with F#, but it's, it's understanding exactly what the code does is not the important thing. It's more trying to understand the way of thinking as you write things in this style. So you got a source, you tokenize it, you parse it, and you flatten it. So F# and all functional languages are very good at reducing your mess of loops and crap and things to very kind of neat description of what you're trying to do. It would be even neater in Haskell, possibly. All right, then I want to apply, when you write a compiler, you have a number of phases that goes through the parse tree, and each phase does something else to the parse tree. Some of them enrich it in some way, some of them do some manipulation and this kind of thing. And so this is generically what a phase looks like. It takes the options, it takes a list of blocks and returns another list of blocks. It takes a parse tree and returns a different parse tree, in a way. And those are all the phases that this guy is gonna through. It's gonna remove the empty blocks, otherwise the text that is written it looks like crap. If you have two blocks that are the same in a row, it's gonna merge them, and it's gonna then go and add the code tags kind of wherever it wants. And yeah, so that's the function that does all of these things. And obviously there is an explanation on top there as well. Yeah, and then it goes on like that. In essence, the thing is a piece of text explaining stuff explained. And in the text, you use those things like this one, for example, to specify how you want your text kind of formatted. Which things are chapter readings. You're really thinking of someone reading this. You're not you're not as much thinking of you're also thinking of the code, but you're really thinking of how this will look like once it becomes a book. Yeah, this is the one for merging blocks. Yeah, I'm not going to go into details. This is the one that added the code tags. And then we flatten the whole thing. And that's, in the end, we end up defining the function that we declare at the very top, the translate function. Now we have all the pieces in place. So if you got some text, you first parse it, and you get your blocks. Then you go through all the phases of your compiler. Then you flatten it, and you get back text again. Okay. So now this is the thing we define at the very top that takes text and return text. And then there is a bunch of things about parsing command line things. That's kind of trivial things. But it's the same model. So you have a parse command line function that takes the command line here and returns the options that we define at the very top. And then I go on to define what that command line does. Yeah, and so on and so forth.
So do you still write documentation for the IntelliSense? Are those exclusive? Are they
if you're writing a library, you could. I don't have a good answer for that. Yeah. I don't know. If you're writing a library, you probably should do that because that's the main thing that people do. And you might have both, or that might end up being two verbose. I don't know. I haven't tried that myself. Yeah. So we can run it. Well, hopefully you can run it.
So the text on the end, you pass it to compiler.
Which text?
Like real F# compiler.
This, yes, this goes into this is a normal F# code. This is normal F# code with just some comments in it. From the point of view of the compiler, this is just a normal F# compiler. It works with IntelliSense works, source control works, everything that you're used to works just fine. Same thing in C. If you were doing this in C, it would be the same. So yeah, so now I built it, so now I can run it. So let me go and run it. So you see what it looks like at the end, at least after all this talking. Okay, so I don't have anything to run. Sorry, I need to fish it out from here. Okay, so I'm running the program on itself, which again is in the tradition of compiler. So that's the program. I'm running it on its own file. I'm saying that the language is F#, and I'm saying that for the open code, I want to use this tag here, and for the closing code, I want to use the tag there. And if I run this, what this produces is this markdown thing, program.markdown, which has been created now, hopefully. Yeah, it's been created now. And if you go inside and you look at it, this is what it looks like. It's in essence what you wrote in the comment, with the comment removed, and with all the code inside this task, these tags here. Yeah, see the F# tag on top and this one at the bottom. This instructs the whatever compiler for Markdown you're using to treat that code as code and give you things like coloring of the code and things like that. So we can generate HTML from that Markdown file, and I'm using something that is called pandoc. Here, pandoc is just something that takes a Markdown file and generates stuff out of it. You can generate PDF, HTML, or whatever you want. So now he has generated that file, hopefully. This one. So this is how your code looks in the browser. And see, we get syntax coloring there. And doesn't look too crappy, I would say, if I can say that myself. And we can also go and generate a PDF from it. It takes a few seconds more, I think. Or maybe many seconds more. So, and this is how it looks in PDF form. So you get a
little bit the font.
Yeah. How do you do that in PDF? Oh, like this. No, that's too much. Is that readable?
Yeah.
Yeah. So you get if you remember, these things was the thing that was at the top of the file, and then it just looks at all the things that you have in your comment and generate a table of content that describes kind of what you have, and then there is all the text, and the code again is here, and it's got syntax coloring, and all the things that you might want to do. So yeah, so that's the code for the tool itself, in a way. So that's kind of how this literate stuff works. You write the code thinking of your reader. In the end, you do produce something that the reader can read. So before you start objecting, let me. Oh, maybe I should show the other code as well. Well, maybe we have a little bit of time. Are you guys still with me? Are you following? Are you following as well? Yes? It's all right. Let's see if I can. If there are C programmers in the room, and I know there are, they have to close their eyes at this very moment, because the C that you are going to look at is not exactly, shall we say, it's a C that looks a bit like Haskell, so you might not recognize yourself there. So this is the same thing in C, the same program in C. I rewrote it in C just because I like C. And it has pretty much a similar, let me see if I can find something really strange. Yeah, like this one is a match statement in F sharp, just written in C, for example. That's a bit of a bizarre thing. One of these days I might do a presentation of this style of writing C code. People will love it. Yeah, this is another one, so yeah. In any case, this is the same kind of thing. You can, you can write it in whatever programming language. In C, it's much easier because you can pre-declare functions, and so you don't have to play tricks with the compiler to help you out. Yeah. All right. On the little projects, this little tool that I have. What's left to do? So what's left to do? Some big things. So that it doesn't do any cross file reference. What you really want is, if you have an application that has multiple files, you really want to have links between all those files, and you really want a way to gather of those files and just write one book that has it's your whole application. It's not, this just works on one file. So that's pretty limited. And then there is also another thing that came up like 1 month after I wrote this blog. This was a blog post originally that Thomas did, that is kind of a bit of a different take on what I just described, but very similar in nature. The difference is that he's still maintaining it and working on it, while I'm not maintaining mine. So perhaps that would be a better choice for you. But it doesn't solve any of the problems that I mentioned up there. And I'm going to continue using mine because I've written it. It does what I need. Some objection to this. What is it? It was before. All right. So the first objection that I always hear is people always, they come from this this agile movement. They always say, well, the code should speak for itself. If you comment it, you're doing something wrong. Is that really true? Do you really write code that speaks for itself? Do you go back 3 years, you read your code, and it's like reading a book? Is that just a fantasy, that the code speaks for itself, or is that true? I've read, in 20 years, I've read plenty of code from the smartest, I believe, at least programmers on earth, and I can tell you, it does not speak for itself. I don't know who came up with this idea that the code speaks for itself. There is probably a good base to it. I mean, you should try to write the code that, as much as possible, speak for itself, but it does not. The code doesn't embed all the alternative solution that you were thinking about. It doesn't embed the reasoning, why it's written in a way instead of another. It doesn't embed any of these things. So it doesn't really speak. It just executes. It might be, the name of the variable might give you some hints of what's going on. It's more like it gives you a flavor, like a perfume of what, of what the code is supposed to be like. But it does not definitely speak for itself. I believe at least. That's my opinion. And then the other question is it takes too long to do it this way? Yeah. It does take longer. It's a double-edged sword, right? What I find, so I've been using these mostly for my personal project that are either small or medium in nature. So I don't have a huge amount of experience. I just have, what I think and what I have experienced myself. And what I have experienced is that when you write code this way, you more rarely take shortcuts with yourself because you are explaining it to someone. And so if you're explaining it to someone, it's a difficult thing to do, to explain to someone and say, I really know that this code should be written differently, but bear with me. I'm doing it this screwed up way, but hey, it's fine. If you're explaining to someone, you don't do that. You go, all right, there is this hack I can do, and then you go, yeah, all right. So the right way of doing it, and then you end up writing it the right way. So you take a bit less shortcut with yourself, if you wish. And also you tend to think about things up front. Because instead of just going, what do I need to write? Okay, I need to write something that takes all the pictures in my folder, it divides it by date, and it does some processing for some picture and some other, and then you go, all right, let b, x, and epsilon. You just stop and you say, all right, what am I trying to do? Well, am I really creating a filter? And you stop and you think about these things because you know that you're going to explain it to someone, right? So your code, in my view at least, your code starts with from a higher ground than it normally would. It kind of it gives you a bit of a check on your tendency to hack stuff out. Now there are, I'm a project manager myself, so there are situations where you do need to hack stuff out. The thing is failing on the farm, your trader is not trading stuff, you need to do stuff, and there are situations like that. But what I've noticed also is that they are rare. You think you're always in that kind of a hurry, but that's not true. It's mostly a mindset that we build for ourselves. Oh, I need to give it to this guy, otherwise the world is gonna fall. And that's mostly in your head. I'm sure there are situations where that's always the case all the time. But I'm also sure that, at least in most of the companies I work with and with most of the customers I talk to, when I ask them what happens if it's a day late, they more often say, well, it's fine. So it might take more to do it this way. I would, from my experience, I would argue that what you get at the other end, it's of better quality. And again, all the studies that they have done on software, they always kind of displayed, it's one of the few facts in our profession. Our profession, I think, is based on myths and kind of travesty and personalities and all sorts of things. But one of the few facts is that you spend way more time maintaining software than writing it. So anything that can make that time shrink by 10% compared to your coded time to shrink by 10% is something that might have value. Then the other kind of objection that I hear is that there is too much text and you cannot see your code. Yeah, I mean that's fine, but once you see your code, so you understand it, right? Because you have written what it does. It might be more difficult to find it, but once you find it, you know what it does. So that's a bit of an advantage, I would say. And then the last one is the one that I like the most. Is this other kind of misconception in our profession that to be a good programmer, you don't need communication skills. You just sit down, punch away at the keyboard, and you come up with something, you give it, and people clap their hands and cheer for you. You guys laugh, but that's what's in our mindset. If you really look deep enough in what you're doing, that's really your conception of a hero. That's what the hackers do. That's what that famous guy that wrote the compiler for the Fugu bar language did in his spare time, writing in a micro screen like this in hexadecimal. He did it all. That's really our ethos. I think that's one of the reasons why our profession doesn't move forward, because our heroes are these kind of guys. They are not, the people who write code that then you understand when you read it. So if you think that you are not good at communicating, I would argue that I don't want to hire you, because you are not going to be successful in any of the companies that I've worked on. I have many examples of mediocre programmers that are good communicators, and they are stars, and I have so very few examples of people that are poor communicators but excellent programmers, and they are stars. They usually end up working in some corner somewhere, doing something no one cares about. After a while, either they get fired or they become hackers or they do something else. But very few of these guys are successful. So if you want to be a better programmer, learn how to communicate. That's the best advice I can give you, because that's often more important than the code that you write. It's very easy to write the wrong code very quickly. It's very, very easy. Yeah. So yeah, so those are just some of the objections I've heard, but I'm sure there are others. And by the way, I'm not suggesting that this is the way of writing code. This is one of the alternative ways of writing code that might be interesting to investigate as a profession. It's not, you know, there are many others, as I mentioned, there are many others ways of doing it. But I think it needs to start with the recognition that we are not succeeding overall, on average. So it's worth looking for other ways. Yeah, okay. Anyone has any other objection? I've seen something that's clearly wrong with this thing. Okay. So there you go. Last but not least, yeah, we are hiring. This is Michael, right here. That's it, right? And there is also an F# competition. I think we have one open at count at this point, in my team at least. So if you think it's interesting, what we do is mostly in F#. Most of our code base is in F#, with a little bit of everything, a little bit of C#. You know, we are a very old company, so we have C#, C++, COM, we have the whole enchilada. My team is mostly doing F#, and in a rather functional way, I would say, because most of the programmers are ex-Haskell programmers. So if you're interested, well, not most of them, that's a lie. Some of them, at least. Okay, that's all I have. Are there any question on this? No? Then thank you very much.